I have a hoop. This hoop has a certain mass, m, and if you look at it, all that mass is right around the outside of the hoop. If we look at a tiny particle of mass over here, that tiny particle of mass has the same radius from the center as a tiny particle of mass over here. This disk is also mass m. But if you look at this disk and think about a tiny particle of mass that makes up this disk, there could be a tiny particle of mass right here at this place. There could be a tiny particle of mass over here at this place. And if these two tiny particles of mass have the same little bit of mass, they have different radii. Over here, it's closer to the center. Over here, it's farther from the center. Knowing that, this disk would have a lower moment of inertia than this hoop. That means that this disk is easier to get to turn than this hoop. And I'll prove it to you. I have an inclined surface over here. I'm going to put both of them up here, the hoop and the disk, at the same location from the top. And we're going to have a race. We're going to have a race down to the bottom. Now, if this hoop has a greater moment of inertia compared to this disk, this hoop is going to be harder to get to turn. So what do you suppose is going to happen if we have a race? Let's check it out. The disk won. The disk won the race because it is easier to get something with a smaller moment of inertia to turn. Just for one more time, started them both at the same location, at the same time. Here we go. The winner is the object that has the smaller moment of inertia.